Rick Hale, Associate Professor, Aerospace Engineering. Developing sensors, developing platforms for remote sensing in Greenland and Antarctica started 5 years ago with a preliminary planning study for what if we replaced the manned aircraft with unmanned aircraft to do the same mission, give us a little range scalability, a little temporal scalability, and take the pilots out of harm's way. That planning study showed, yes, we should in fact look at uninhabited aircraft, and we started designing it. It was designed at KU, built at KU. We've spent the last 3 years then, well, a good year, working with the scientists on what are the mission specifications, working with the sensor technology folks on how far can you miniaturize, how much can you lightweight the structures and sensors, and then designing an aircraft around that. We would have liked to procure an aircraft, but there just wasn't really one available for the low altitude, reasonably long endurance mission that we're talking about. We are now in ground test and flight test phase. We're in the process of taxi tests, and we should be doing flight tests within a month or so. There's a limited number of manned platforms available, and so it's not a very scalable process. You can't find that many more pilots. The pilot also limits the endurance of the mission because the pilot has to come in and take a nap. The aircraft also burn about 20 times more fuel than our uninhabited aircraft does, and we have to bring all the fuel in. So all of those things, I think, lend themselves to considering an uninhabited aircraft. It's risky. It's an advancement in the state of the art. There's no question about that. It's bringing Department of Defense technologies into pure science-based applications. The payoffs exceed that mission because the same sorts of technologies we need to improve the next generation of air transportation are the ones we're developing to keep these aircraft airborne and safe to operate. It's fairly exotic the way we're manufacturing these aircraft. Our UAV is not small. It's the size of a small single passenger aircraft or 2 to 4 passenger aircraft. It's about 1,100 pounds, 26-foot wingspan. That's as small as it can be for the sensor technology today. Those sensors will keep miniaturizing. So it's a very capable uninhabited aircraft. That allows us to fly like a general aviation aircraft will fly. Iridium, satellite communications, over-the-horizon communications, global operation. Right now, all digital, all fly-by-wire. Fairly unusual for vehicles of this size to be that advanced in control technology. And where we'll be in the next 5 years is in looking at the autonomy, increasing the autonomy, the intelligence of the systems, the ability of the platform to make decisions for itself. It's not uncommon in research that the students do all the work. They have the time to commit to it and the energy and enthusiasm. But this project is particularly immersive, and it is so from undergraduates through postdoctorals and faculty as well, and staff as well. Right now this summer we've got 21 people on the payroll, students, undergraduates and graduates, and about equally split. As you know, this project is absolutely integral to our curriculum. It's in almost every course. There are 17 different courses that as the capstone final project, the end of semester project, do something immersive related to this aircraft, something that we're doing in parallel in research. So the undergraduates are integrally involved with everything that we do. And I've got computer scientists, electrical engineers, mechanical engineers, aerospace engineers, physicists. You have to think bigger now if you're trying to recruit because there's geologists and glaciologists and journalists and English majors. There's lots of folks helping this. Design students helping us with paint schemes that are visible, helping us with how to present this information to the general public. Just about anybody can get involved. The reality is that transportation, air transportation, is one of the top 3 industries in this state. I guarantee you those folks are interested in aircraft that are easier to operate, safer to operate. I guarantee you that there are aircraft which are currently certified for 2 pilots. They'd very much like to have a 1-pilot option. So you've got to take the pilot workload issues off the pilot and give it some automation. Same technology. The students who come here will be very well trained. In my department, I'm proud of my students. I would put them up against any program in the country. They get more practical experience because our faculty have real-world experience and we involve them in the research. So that's a clearly win-win situation. And then those students go to work for our local industries and the worldwide aviation community. For a student coming here that wants to get involved right away, it happens. I've had students work for me from freshmen through their doctoral program. So we can engage them here, or we can prepare them to go on to their next phase. They can get as involved as they want to be. So, and we're only talking about the large project. We have 40 uninhabited aircraft, ranging from handheld up to this large 1,100-pound one.